Okay. Can you all see the second question?
Yes.
So what second question is, we have given a board like and with all the characters, and we need to find the particular word like this if it is present in a grid or provided board or not. And we can move uh, horizontally as well as vertically. Like adjacent cells, we can move horizontally as well as vertically, right, left, up, and down. So, and the main thing is the same letter may not be used more than once. So, for example, here the word is A, B, C, C, E, D. While traversing over here, A, B, C, down, C, E, and D, we got an answer, and this is true. Similarly, S, E, E. So from starting over here, or if we can say if we have one S over here, if we go above, down, right, left, we can't see the E. So we just return false and we'll be moving further. And here we got C, and here we can say start with S, then E, then E. Then it will be true. And if we are over here, A, B, C, B, we have given the A, B, C, B. From here, A, B, C, B is not present. Similarly, over here also we have A, and if we start traversing from over here also, we are not getting an answer, so it is returning false. So this is a basic problem. Anyone has tried? Like I tried. Any approach coming in their mind?
I do the
something similar which
I
we
did
did
the depth
yesterday.
first search.
Sorry, there is two people are speaking.
I'm sorry, go ahead.
Go ahead.
No, I was saying that I'm doing the depth first search.
Yeah.
So for each cell in the matrix, you know, I do the depth first search and try to find if it match the word.
Like moving a depth first search, if we found a word, we'll be returning true. And what if the case we didn't find the character which we are looking for it?
Then
So
we
what
move we move to the next cell in the matrix.
And we need to do the backtracking as well.
Yeah, for every cell we need to do the no backtracking, just like depth first search, you know, from that cell.
So basically, if we used a cell in one path, we can't use that again. So basically, so in this example, if I'm going from A, B, and then going F, and let's say I'm going S, A, B, F, S, then I can't take upper A. So
That's
basically,
true.
we have to also account like I have visited that person. And if I couldn't get the answer, I have to make it unvisited. Like we did something similar yesterday also.
Yeah, we did with the backtracking problem only.
Yes, take the first case where we start with A, B, then C in the first row, and then C at the bottom. Okay, like in the middle row, and then like E, which is in the last row, and then from there, let's say instead of going left, which is D, what if we go to the right, which is E?
Yes.
Okay, so we go to the E, then we see, okay, it's not matching, then we backtrack, and then again go back to the same E, and then go maybe left from there. So it's a very classic DFS with the backtracking problem.
Yeah.
Very similar to the one that we discussed yesterday, where we have to go from number 1 to number 2 in a 2D matrix, covering all the zeros.
Yeah, similarly like that. proper.
That has one more constraint that we have to
pass all the zeros over there.
Yes.
yeah.
Yeah.
But the base idea is like very similar.
Yeah, basic.
Yeah. Like their end condition was we need to complete all the zeros. If it is not completed, then we are not returning an answer. So over here, if we complete all, like if we have reached the length of the word which we need to find, then we got an answer. So basically, it's like that. So I have solved this. If anybody wants willing to see, then I can open it up. So,
Is
but
there a different approach than the depth first
no,
search
it's similar
or
depth first
backtracking?
search, depth first search with backtracking. It's the
No,
approach which.
I think the question is like, is there any other approach? Or...
Oh, okay. Anyone has tried any other approach? I'm curious. Breadth first search will not work over here, correct?
Because we want to go in depth.
Yeah.
It works too, but it takes time. And it consumes extra memory.
Mm-hmm.
Yeah, that's also true. And so what if we have various words and we need to find all the words like in that grid. So for example, these are all the words which we have provided, and we need to tell what all the words are present in that grid.
So I think you are looking for, there is a, I think similar question, word search 2, or probably you can open, it should be down somewhere. But before we discuss that, is there any doubt or confusion on this approach using DFS?
Yes, like and also like how the VFS will work here. If you want to like elaborate like more on it.
Sorry?
BFS, I think how it will work, you'll start from A, you start visiting your neighboring nodes. And every time you visit, at every level, you try to see, are you going in the right direction? For example, what will be the neighboring nodes? A, B, A, S. Then AS is not AS could not be a candidate because the given word is A, B, C, C, E, D. So AS we will not put that in the queue. And we'll put AB, and we'll also put B's index. B's index is 0 and 1. Then from B, now the string which is in the queue is AB. From B, I can't go back A. I can go F, C, C. I can go A. Can't go towards A side because that is visited. I can go towards
C and F.
C. I can go towards C and F. So if I put F, if I take F as a candidate, it won't work because there is no F at third position, at third level, I will say in BFS. I'll ignore that and then take C.
So
then it will become APC.
So in
my
these
queue.
scenarios, like in these scenarios, like we won't put the neighbors in the queue unless like they satisfy the condition.
Yeah, if they qualify, then only put the neighbor in the queue.
It will be requiring extra memory over here.
No, in DFS also we are doing extra memory as stack.
Yeah. So here also will be like if we take a queue, we are taking a queue. Then also it's but you are saying we'll not put the neighbors which is not qualifying.
Yeah, which doesn't qualify.
Okay, we'll not put them. So while putting in a queue, we'll be just like make a string like something to append in a queue.
Yeah, make a string, or even we don't need to put a string. I think we are going level by level. So we can even just put the next, what would be the current index should be in the queue. So first it will be A, then it will be index of B, then it will be index of C, then it will be another index of C. So we'll go one by one, like from there, can I visit my neighbors? It's something like that.
So I have a question. So let's say at any given point of time, 2 or 3 neighbors are satisfying the condition.
Yeah, so we have to go in all directions then.
To keep it simple, let's say 2 neighbors are satisfying the condition. So as per the algorithm, like we will put like those 2 neighbors. Okay, but let's say the condition, like the constraint, or later on, like we find out that one of the neighbor, okay, which we thought may lead us to the solution, okay, is not working, like not leading us to the solution, but the other neighbor will lead us to the solution, but it will go to some path, and also other neighbor, okay,
which is already visited.
Which is already visited. So in these scenarios, like I believe when we are pulling them out, we have to make sure we are unmarking all the neighbors which are not satisfying the condition.
Okay.
And we have to go all the way back. Okay, so let's say like A, B, C, E. Okay, and A, B, C, E. On the first row, I'm just like taking some arbitrary example, and we also have like A, B, C, E, like in the first column. Okay, so while we are going to A, B, C, E, like in the first row, we figure out, okay, it's not going to satisfy our condition. Okay, then we have to backtrack from there. We have to like remove E, C, B. We have to mark all of those unlisted. Okay, because maybe while we are going through the column, okay, there is a path, but that path may include the letters which are on the in the first row. Okay, so I'm not sure like in this scenario the BFS will work or not.
So we need to in that BFS, actually the problem is we need to backtrack all the elements while going back.
Yes.
Yeah, it may because there could be paths that overlaps.
Yeah.
And when we backtrack and let's say we mark it unvisit, then later, you know, when we go again, then we go the same path again.
Yep.
So so then
it should take more time.
Yes,
it will not go into infinite loop, I think, but it would take more time.
Yeah, time complexity would be high.
No, but I don't think like the BFS like will work over here.
Yeah, BFS will be tricky here.
Not tricky, like I don't think like it will work.
Why you think it not work?
Because let's say like we are like into some path, maybe deep down, and then we found that like that path doesn't lead us to the solution. Okay, then we have to find a way to mark all the nodes in that path as unvisited. Okay, because if we are in the DFS, okay, we have this recursion stack which we can roll back to and like keep marking all the nodes as unvisited up until we are at some higher level from where we can go to another direction. But in case of BFS, we have to keep track of the path that we came from. So in that case, like we have to mark all the nodes in that path as unvisited, so we can use them later while we are coming from some another path. Does that make sense?
Because let's say if you at B right now, right, at the row 0 and column 1, and let's suppose that two C, one on the right and one on the bottom, right? So you would save two the coordinate of that 2C on the queue, right? You save the coordinate of the neighbor on the queue. Then when you process one path from one neighbor, if it does not work, now you process the path from the other neighbor, because you have both of them on the queue.
Okay, but I need I believe we have to take an example.
And I think because each neighbor have unique coordinate, I mean, a unique row and column, so it would take to it would take us to different path. That means it potentially could take us to the solution.
We need to take an example, otherwise it won't be clear.
Yes.
So
okay. Can I share the whiteboard? Okay.
Because you're looking for an example where there are two different paths, and also we need
to come back
to some of the nodes in a path which doesn't lead us to the solution.
So put A, B, C, D.
Or maybe, hey Sonia, instead of writing, maybe just use the Leetcode bold, like the solution area. So maybe you can copy paste the letters. It should be easy.
Oh, okay.
Yeah.
I'll just do that.
Because if you have to modify them, it should be easy to modify at that location. So just share your Leetcode window.
Okay, yeah, I'll share that only. Okay, so
yeah, maybe you can write it at the.
So we just need to append over here, for example, D.
Yeah, and just to make
So the main thing is, let's see, we are looking for
yeah, just to put instead of F
with C.
Instead of F, put
C there, right? Because they both have the same neighbor.
C, and your word is AB, CCB.
CCED. Okay.
ECCB.
Yeah.
So for example, in a queue, first of all,
it would be A.
Okay. No, but this solution is not going to work because we need another B here because we only have single B.
Yeah. So let's say we have A, B, C, C.
A, B, C, S, that file, A, B, C, C, S.
Yeah, A, B, C, C, S.
Okay.
Now let's put it on the queue. Put A, let's say we start from the A first, right?
Yeah.
So then A is gone.
Yeah.
So you can put AB now. And then you can put
C, which is down one.
So both the C's can come, ABC and ABC. Two ABCs can be in the queue now.
So I'll pop it up.
Yeah. And then put ABC.
Okay, ABC and one more.
And then there will be another ABC.
You only put C, right? Because let's say you have A in the queue, and when you take it out and you look at the neighbor of A, and now the neighbor of A is B, then we only put B on the queue.
Yeah, no, for simplicity, we're just putting how the flow would be.
Okay. So now we have put the neighbors of ABC and ABC, which B has 2C, right and down. So we put that in a queue.
Yeah, then so that ABC is next to the first row one ABC.
Yeah, so first is this ABC and one is then AB and down C.
Okay, So now you remove the first ABC and then you can,
There is a D also.
yeah, D we can't go,
Yeah, so I'll go with the down one, which is C.
which is ABCC.
Okay.
And now the first ABC will leave the queue,
Yeah,
and it can't put ABCC. It cannot put ABCS.
because we need another C. It can go with the that C also.
But that C is visited, if you see. So that's
Okay.
what I think Gaurav was telling. We have to unvisit it if we are not using it.
But you have to consider the backtracking. So when you will go back, you
Yeah.
can.
So this is like not a DFS solution we are discussing. It's a BFS where backtracking could be. So here what we are discussing, like in BFS, can I do a backtracking?
So yeah, so that's why Gaurav is saying we need to unvisit it before moving further.
And
Yes, Tony, I shared like one good example.
Okay.
Okay, like if you take a look at the chat.
Yeah, I got it.
Like just give it a try, like with this example.
So okay, and our target is to reach
It's in the chat.
yeah ABBCB. So ABBCCB. So
take the example in this case. Like this solution. Okay, first column A B B C C.
yeah,
Okay, and the only solution that in this case is A B B. If you go to the top row, okay, A B B, and then we have to go down C C, and then all the way to the left.
yeah,
Okay.
that's an answer.
Yes, that's an answer. But in this case, like what will happen if we start exploring A B B C C, which is the first column?
Mm-hmm.
Okay, so while we reach the bottom row, while we are exploring the first column,
Mm-hmm.
okay, we find that we don't have a solution, so we have to roll backtrack all the way back to the A, and then mark everything unlisted.
So for example, the first column is ABCC over here, but we need one more B and we can't reach over here. So we need to all the way go back and need to start again from here.
Yeah, try that algorithm, like how the BFS will work. Like,
So
like
here
from the start.
it won't work until we go back and clean the things.
Yeah, we need to, that's why I'm like, if we are coming over here, it will start from here, A, B is right, then B, C is right, C is right. And, but we reached, we need one more B and it is not here. Like all the children of last C doesn't contain any, or children or the adjacent cell doesn't contain any B. So it needs to traverse back all the way and check another like B.
Otherwise, it won't like the other solution to use that B.
Yes.
So I believe like the BFS will work only in this case if somehow like we keep the route that we are coming from. Okay.
Yes.
So
Yeah.
once we figure out, okay, we don't have a solution through a certain path. If we know the route that we came from, then we can unmark like all the way to the wherever needed.
The thing is like then everyone has to maintain their own route.
Yes. So
they can't share like a common visited matrix or something like that.
Yes. So that's why I'm saying like DFS is a straightforward solution. BFS may work. I'm not sure like it will still work or not, but we have to add like a lot of additional logic to make sure we have to backtrack. Okay, mark everything as unlisted, and up to what point we have to mark everything as unlisted.
Yeah, because you need to track which index or which value you visited. right? Because you don't want to keep going on to the same value again and again.
So also one thing is like if we are traversing all the way, like if we are reaching to one path, going for one path, and its neighbors, we need to say that all like this is also these are the neighbors of uh, these are the neighbors of B, and then this is a neighbor of again B. So, but we are going to the neighbors, but the initial neighbor would be need would set in a queue so that it should not uh, we should not remove it. Also, that's also a constraint, I think. So, for example, if I have put A's A B and one more A B, so because the neighbors are A B and A B, and here all the way we and if it is not reachable from this particular path, then then uh, then this would be unmarked and then it would be going back over here. So but the thing is we'll be reaching if side by side another path is also going on.
So basically, we don't need to do this visited thing. If I have to do a BFS solution, I won't maintain any visited thing. I'll find other way so I am not stepping over the things which I have already done.
But one thing is like if we are traversing, if another path is going over here and when it is reaches towards here,
Yeah,
B,
you
but
can use that B.
already listed.
So basically, instead of putting a index in the queue, I will also put two things in the queue: a set of all the things which I have visited, something like that, or I will come up with a pattern. So if you see here, uh, if I go from A to B, my either I'm going in one direction, like my index is increasing. So somewhere there would be a pattern, like either I'm going up or I'm going left, right, bottom. So I can use some kind of pattern to identify I'm not going back.
Yeah. Yeah, we need something to think
I
about it.
agree
I
with
think
that.
we should move on for the next
Yes,
question.
let's do
And
that.
yeah,
This is
so
this is a good discussion. Give it a try. If there is a solution, like please post it on the Slack so everyone can benefit from it.
yeah, exactly.
And meanwhile,
But
can you want to follow up on the other one which we are discussing, word search too?
I think we have just 15 minutes and we need to go for the last question. So that's I can show just one that like this is another problem similarly like this. Sorry. And what it is,
So basically here, I think we just want to find every word.
yeah, so we have given a words and we just need to find the word which exists in this grid. For example, over here, oath and eat exist. So our output are those words which exist. Like how we returning a true, we need to return the true values which are existing in a, we need to return the strings which are existing in a,
So I think one approach is like take each word and do the same operation which we did in the last.
yeah.
Uh,
So that's the particular approach, I think.
but is there can be a because now what I'm doing, like I'm taking one word and doing the entire operation. Then so basically the complexity would be if there are m words and the grid is n by n, the complexity would become m into n into n.
Yeah, because we need to traverse all the words and we and the complexity also and as well as all the space complexity also.
Space would be like kind of constant only n by n. We'd be using the same visited one.
Yeah.
Or yeah, if we are doing a stack solution, yes.
Hey, I believe like we can move to the next question because
Yeah. So